Beyond the frozen orbit of Saturn, our instruments have pierced the veils of gas and ringed shadows surrounding Uranus. There, in the dim light of the distant sun, a new world has come into focus, a hidden moon unseen until now. Detected by the unparalleled vision of the James Webb Space Telescope, this discovery adds a fresh chapter to the mysteries of the ice giant, reminding us how much of our own solar system still waits in silence to be found. Uranus, the seventh planet from our Sun, has long been a mystery cloaked in blue-green haze. At nearly 1.8 billion miles, almost 20 times farther from the Sun than Earth, Uranus is a world of extremes. For centuries, its secrets have remained largely untouched, its true nature obscured by distance, darkness, and the limitations of our technology. Yet today, we stand on the threshold of a new era in planetary exploration, one where even the faintest glimmers of light can spark extraordinary discoveries. The story begins with a series of long-exposure images, each one lasting 40 minutes, captured by the James Webb Space Telescope's near-infrared camera. The telescope, orbiting far beyond the moon, is equipped to see what no human can. The faintest hints of sunlight reflecting off tiny, icy objects billions of miles away. In this case, JWST's ultra-sensitive detectors picked up a subtle glint of light, hidden deep within Uranus's dark inner rings, a region so densely packed with dust and debris that it has eluded the gaze of every other telescope and spacecraft to date. That faint glimmer, almost lost in the cosmic night, was no trick of the eye. Astronomers soon realized they were witnessing the signature of a newly discovered moon, temporarily dubbed S2025-U1. This tiny satellite is just 6 miles, or about 10 kilometers, across, so small and faint that even the legendary Voyager 2 spacecraft missed it during its historic flyby of Uranus nearly 40 years ago. S2025. U1 is now the 29th known moon of Uranus, and its discovery is more than just a numerical milestone. Its existence hints at an even richer, more complex system of moons and rings than scientists once imagined. No other planet in our solar system boasts as many small inner moons as Uranus. These moons, each weaving its own path through the shadows of the planet's rings, are locked in a delicate gravitational dance that blurs the boundary between what we call a ring system and what we recognize as a system of moons. The new moon itself orbits about 35,000 miles, or 56,000 kilometers, from Uranus's center. Its path is nearly circular, suggesting that it may have formed close to its current location, undisturbed by the violent disruptions that have shaped other planetary systems. But S2025. U1's most striking feature may be its location. Nestled within the planet's dark inner rings, a region so densely shrouded that it's become a blind spot even for our most powerful telescopes. It's this very hiding place that kept the moon invisible until now, underscoring how much remains to be discovered in the distant reaches of our solar system. To understand the magnitude of this discovery, consider the legacy of Voyager 2. Back in January 1986, Voyager 2 gave humanity its first close-up look at Uranus, revealing a world far stranger than expected. It mapped the planet's 5 major moons, Miranda, Ariel, Umbriel, Titania, and Oberon, and uncovered a system of rings and smaller satellites. Yet, even Voyager's keen cameras and instruments could not pierce the planet's inner darkness to find S2025-U1. Only now, with the advanced infrared eyes of JWST, has this tiny moon finally come to light. But why does this matter? Every discovery in the outer solar system opens new questions about the origins and evolution of planets and their companions. The small moons of Uranus, including S2025-U1, hold clues to the planet's ancient, chaotic history, a history marked by collisions, migrations, and perhaps even the capture of foreign bodies from the distant Kuiper Belt. Their orbits, their compositions, and the complex interplay with Uranus's rings all tell a story written over billions of years. The very naming of Uranus's moons is a nod to the stories we tell here on Earth. Following tradition, S2025U1 will likely be named after a character from the works of Shakespeare or Alexander Pope, joining the likes of Miranda, Ariel, and Titania in a celestial cast of characters. The final decision rests with the International Astronomical Union, the global authority on naming objects in the cosmos. The discovery of S2025U1 is a testament to the power of modern astronomy, where each new mission builds upon the achievements of those that came before. From the pioneering flybys of Voyager to the revolutionary observations of JWST, our window into the universe grows ever wider, revealing not only the grand spectacles of galaxies and nebulae, but also the faint, hidden worlds lurking at the edge of our own solar system. As we peer deeper into Uranus's rings, astronomers are left to wonder how many more secrets are waiting to be uncovered in the icy shadows. If such a small moon could escape detection for so long, could there be more lurking just beyond our reach, waiting for the next wave of innovation to bring them into the light? This is the lure of exploration, a journey defined by questions, surprises, and the thrill of the unknown. Thanks to the sharp eyes of the James Webb Space Telescope, Uranus now claims a 29th moon, an icy, diminutive world just 10 kilometers across, concealed for eons within the planet's shadowy inner rings. The moon, temporarily designated S2025U1, eluded all previous detection by virtue of its faintness and size, invisible to telescopes on Earth and even to Voyager 2 during its historic flyby nearly 40 years ago. It was only through the extraordinary sensitivity of JWST's near-infrared camera, NIRCam, that astronomers teased out this tiny moon's presence. Over a series of painstaking 40-minute exposures, the camera captured fleeting glints of sunlight reflecting off S2025U1 as it traced its nearly circular orbit, a signature too subtle for any previous instrument to detect. This discovery is a stark reminder. Our own solar system is teeming with hidden structure, still waiting to be revealed. S2025U1 now joins a bustling family of inner moons, bringing the total count of known satellites orbiting Uranus to 29. 14 of these, including the newcomer, form a tightly knit system inside the paths of the planet's 5 large classical moons: Miranda, Ariel, Umbriel, Titania, and Oberon. Orbiting just 56,000 kilometers from Uranus's center, S2025U1 glides within the planet's dense inner ring system, one of 13 rings that encircle this distant ice giant. These rings are divided into an intricate inner array and 2 fainter outer belts, further complicating the region's gravitational choreography. This tiny 6-mile-wide world, temporarily named S2025U1, eluded our gaze for centuries, its faint glimmer lost within the shadowy embrace of Uranus's inner rings. Captured at last by JWST's near-infrared camera, its subtle sunlight was brought to light through painstaking 40-minute exposures, stacked and analyzed with the precision only today's technology allows. This moon's discovery is not only a triumph of instrumentation, but of patience and ingenuity. Voyager 2, the lone spacecraft to ever visit Uranus, could not spot it during its historic 1986 flyby. Ground-based telescopes, even the mighty Hubble, missed it entirely. Only with JWST's sensitivity, orbiting far from Earth's atmosphere, could we finally pick out this elusive speck. It is a reminder, a humbling one, of how much remains hidden in the outer reaches of our own solar system. Let's linger for a moment on what makes Uranus's moon system so remarkable. With 29 known moons and counting, Uranus has more small inner satellites than any other planet. 14 of these, including S2025U1, orbit within the path traced by the planet's 5 major moons: Miranda, Ariel, Umbriel, Titania, and Oberon. These small moons weave through a labyrinth of 13 narrow, dark rings, their orbits shaped by mutual gravitational tugs and by the planet's own strange tilt. The rings and moons interact in ways that hint at a past both violent and chaotic, a history in which collisions, tidal forces, and perhaps even captured objects from deep space have sculpted a system that blurs the line between moon and ring. The moon's nearly circular orbit, nestled 35,000 miles from Uranus's center, suggests that it has remained close to its birthplace. Its proximity to the densely packed inner rings hints at a complex, dynamical environment, one where moons can be torn apart to become rings, or where ring material may coalesce into new moons. 2025. U1's diminutive size and faintness suggests that Uranus may be hiding even more secrets among its rings, perhaps entire families of tiny worlds awaiting discovery as our instruments and methods improve. This discovery also reaffirms how our understanding of Uranus, and indeed of all the outer planets, is still evolving. The data collected by Voyager 2, once thought to be definitive, have been revised and reinterpreted in the decades since. Each new observation, each fresh dataset from JWST or other telescopes adds layers of nuance to our models. We used to think the composition of Uranus and Neptune was well understood. Recent research suggests otherwise, pointing to new mysteries involving exotic ices and unexpected atmospheric dynamics. Scientists have even found that the dark sides of Uranian moons are oriented in puzzling ways, a sign that there are still fundamental questions about the mechanics of these distant worlds. The naming of S2025 U1 is still pending, but tradition dictates that, like its siblings, it will be named after a character from Shakespeare or Alexander Pope. This poetic convention connects our modern explorations to centuries of human culture and imagination. There is something fitting in that. As we map the cold, distant moons of Uranus, we reach back into the world's great stories, giving names to what was once invisible. But beyond poetry, these discoveries have practical significance. They inform our understanding of planetary formation and evolution, not just in our solar system, but in the countless planetary systems now being discovered around other stars. The interactions between Uranus's rings and moons, their chaotic history, and their ongoing evolution are a laboratory for planetary science, a window into the processes that shape worlds everywhere. JWST's success in finding this hidden moon is also a preview of the discoveries yet to come. Its unprecedented sensitivity will continue to probe the outer solar system, searching for new rings, new satellites, or even faint atmospheric phenomena. Meanwhile, astronomers are already planning ambitious missions to Uranus itself. Proposed spacecraft would carry advanced instruments to orbit the planet, image its moons in detail, and probe its mysterious, tilted atmosphere. These missions would build on the legacy of Voyager 2 and the breakthroughs of JWST, bringing us closer than ever to understanding this enigmatic planet. As we reflect on these milestones, it's important to remember that every discovery is a step in a much larger journey. The outer solar system, with its icy giants and their retinues of rings and moons, remains a frontier. There are surely more surprises awaiting us, unseen worlds, unexpected phenomena, and puzzles that will challenge our theories for decades to come. The story of Uranus's 29th moon is a vivid reminder. Even in the familiar territory of our own solar system, there is still so much to explore. New technology, new missions, and the tireless curiosity of scientists will continue to reveal wonders at the edge of our knowledge. If you've enjoyed this journey through the mysteries of Uranus and the search for its hidden moon, make sure to like this video and subscribe for more content like this. There's a whole universe of discovery ahead, and we can't wait to share it with you.